We'll start off now with the last talk for the day. After we will go to the party. Hopefully most of you will join to get information later on it. I'd like to introduce to you Kim. He's working as a consultant at Beck in Norway, has also around 10 years experience as a web developer, and he will talk about patterns of large-scale JavaScript applications.
Yeah, thanks. So last talk of the day is you're probably getting ready for the party. We'll have like probably around 40 minutes about large-scale JavaScript apps. So yeah, I work at Beck. It's up in Norway, in Oslo. And you can find my webpage and my Twitter handle here. So what we're going to talk about is large-scale JavaScript apps. And when I say that, people, they tend to think like that has to be at least 20,000 lines of code, perhaps 50,000, maybe 100,000 lines of code. But really, it isn't all about size. Large really doesn't have to be that large. You have a lot of other stuff that's part of building JavaScript apps. For example, you could have a complex domain. For example, if you work in insurance, banking, a lot of other businesses, you could have a lot of developers that needs to work on a project. It could be an app that's going to live for maybe 5 or 10 years. Some of the apps I work on as a consultant has a really long time span. That's some important stuff for example, insurance in Norway, that they want to build something now and have that stuff live for at least 5 years. You should also be able to adapt to changes. For example, what if the laws change? What if some competitor comes and does something really cool and you have to compete with that? And lately, at least the last couple of years, we've seen a lot of focus on testing. And testing some of the stuff that we write, have written before at least, has been really difficult. So I think that's part of building a large-scale JavaScript app, just being sure that it works when you add new stuff. If you have 10,000 lines of code and add functionality, it's hard to know that everything still works. And you can have unknown unknowns, things that you just don't know when you start up. So there's a lot of stuff here that we need to think about, so it's not only size that is important. And I think that the main problem with JavaScript is that we always start with just a small feature. We need to add some dynamic, some interactivity to the HTML. And we start with just these 5 lines of code. So we click a button, we get some data using Ajax, and we update the DOM. And suddenly you have 5,000 lines of code in a single file. I've done this many times before. And you're just thinking, how did this happen? Because it tends to happen all the time. I think this is a great term for it. There was a presentation by a girl called Amy in, I think it was in New Zealand, where she talked about how she built her Backbone.js applications, and she called it JQuery soup, what we have used to do this last couple of years. So you create this brittle, tangled mess of a code base, which is both hard to read and understand. And perhaps the worst part is that it's hard to reason about. Just understanding what's going on in the application is hard when there's so much stuff going on at the same time. So I guess we could go back a couple of years to 2006, where we had this focus on unobtrusive JavaScript. We had this amazing blog post by Jeremy Keith at Listapart, where he talked about splitting CSS from JavaScript and HTML. So the state of the web was quite different back then. So what you usually did was you delivered some HTML to the front end and started unobtrusively adding features using JavaScript. At the same time, in 2006, we got jQuery. So at the time, we had IE6, IE7, we had Firefox 2, and a lot of old browsers. So we really needed jQuery because we were in browser hell. The problem is that the way we started using jQuery for everything ended up in a couple of anti-patterns, at least what I think are anti-patterns. So jQuery is amazing for handling the DOM, but it's easy to abuse. Just checking out some examples. We have here We find some place in the DOM, and we start traversing like crazy everywhere. So now, if you just change your HTML, you end up breaking your application. And it's really easy to do. And when your app is 5,000 lines of code, 10,000 lines of code, it's easy to end up breaking something. And also because it's quite hard to test some of these applications, it's actually hard to see that stuff is breaking. And the one at the bottom here is just you have this crazy selector to find stuff, and it's the same problem. Another thing we tend to do is that we put everything inside document ready. So in document ready, we have this anonymous function, and inside there, our entire application lives. 5,000 lines of code inside. And the problem here is that being able to test this stuff is really hard. We have no way of getting into that code without setting up the entire DOM and getting everything up and running. And the last one is pushing state to the DOM. So you just serialize data into a DOM node. And this might be okay in for some things for the front end, but pushing state in here might end up as a really bad problem for you. I think that making the DOM the source of truth in your application is a bad idea, because the DOM is inherently global, and it's also really hard to reason about what's going on when there's a lot of stuff in the DOM. So this is the biggest problem, I think. The business logic is hidden in this mess of code. So you have code that both works on the DOM and does a lot of stuff with the DOM. There's a lot of AJAX requests, and you also have a lot of business logic in there. That's important. If you want to change how you work with your front end, just change the layout. You should still be able to keep all the business logic that you have, all the special rules that are for your insurance website or for whatever website you're working on. So the thing is, it's easy to create a tangled mess. And what happens when the requirements change, when you need to do something new here? Just as an example, we can see this. This is 11 lines of usual jQuery stuff. The problem is that there's a lot of stuff going on here. We listen for document ready. We set up a user event on a form. So we listen for the submit. We hit the server. We have a nested callback on success here. We parse the response. We do templating. And we have this structure that's just going further and further in. Callback hell. So this is not a problem at all for small apps. It's not. I do this for several small sites I have. It's no problem at all. But what about, for example, here? We haven't handled errors, so we have no error handling here. We should think about that. Maybe we have some similar error handling in the entire application. You need to set that up every time. And there's a lot of stuff here that might be similar for all AJAX requests or for all submits to a form and stuff like that, and we need to code that every time when we do it like this. So I would just say that this is unmaintainable and untestable. And the problem is when we have this considerable increase in the amount of JavaScript. Because we want to have more interactive pages, we just end up pushing a lot of complexity into our front-end application. Because now we want to have highly interactive front ends. It doesn't have to be single-page applications like the new Google Maps. It can be a page where you push all the HTML, which is rendered on the back end, to the front end and add stuff there. But still, we end up pushing more and more stuff here to the front end. Another thing that we've seen is that we're just pushing functionality from the back end. It's not just adding more interactivity to the front end. We're also pushing logic from the back end to the front end. And we have these new capabilities. We have WebSockets and Canvas, geolocation, web workers. There's a lot of stuff going on in the browser right now. And I think that the biggest problem is no longer the browser. It's the size and complexity of our apps. And I saw this amazing presentation by Brandon Keepers, who works at GitHub, about a year ago. You should really check out this presentation. Yeah, you can see the name here, so you can search it on Google or something. He says that the litmus test for your application is that if your site or application breaks without JavaScript, you should treat JavaScript as a real language. And he talks at some length about that in his talk, what he sees as treating JavaScript as a real language. And I'm going to focus on creating testable, scalable, and maintainable JavaScript. This is what I've been working on for the last 2 or 3 years at my company in Norway. And this is actually quite difficult. It takes a lot of time to learn, and it's very hard when you have a lot of developers. Not everyone is ready to do new stuff or rethink the way they do JavaScript today. And I think that we need to unlearn a lot of stuff about how we do things. We have learned from about 2006 when jQuery came. We've started adding more and more stuff on top of jQuery. So we have a lot of jQuery plugins. We have a lot of stuff going on. And we tend to follow a lot of anti-patterns. So it's easy to create brittle systems. So the first thing I think we need to unlearn is our DOM-centric approach. We're so focused on having things in the DOM. The thing is that the DOM is inherently global and stateful. So it's this singleton that we push stuff onto. So it's really hard to test, because in the test, you need to have the DOM present. You need to work on the DOM. And this is actually really hard. And it's also hard to reason about state. So what's the current state of the application? To find out that, you need to actually go into the DOM and find out all that information. And we need to unlearn how we write JavaScript. So no more 5,000 lines of code in a single file. And you should really watch out for global variables. When you have global variables, it's really easy to change some part of the site without actually meaning to change some part of the site, because that part of the site is also using this global variable. So global state is really hard to work with in a large application. And I think here that we should learn from the backend. I work a lot with Java. I know a lot of people hate Java, but they have worked on building really large applications for a lot of years, 20, 30 years. And they have learned a lot about it. So we should learn some of those things and see how we can apply them to our JavaScript. And the last one, we need to unlearn how we use jQuery. And I think this is a great quote. I'm going to quote this book a couple of times. It's called Growing Object-Oriented Software Guided by Tests. It's a Java book, but it's perhaps the best testing book I've read ever. They say that their experience is that when code is difficult to test, the most likely cause is that the design needs to improve. So I think that what we mainly need is structure. So that's mainly what I'm going to focus on for the rest of the presentation. Justin Meyer created a framework a couple of years ago called JavaScript MVC, one of the first MVC libraries for JavaScript. And he said that the secret of building large apps is to never build large apps. You should break up your application into small pieces and assemble those testable and bite-sized pieces into your big application. And I think this is an interesting way to think about it. Instead of building this large, huge stuff that is within jQuery document ready, we should build small pieces, and we can just start them in document ready. So we've got a lot of frameworks and libraries now to help us here. We have Knockout, for example, Ember, Backbone, and Angular. These are perhaps the most famous ones, but there's probably 1,000 MVC-type libraries right now. So they're trying to help solve the problem here. They have a little bit different philosophies. We're going to take a look at some of those things, because I think we need a foundation before we're able to choose which of this we want to use, and just to understand the actual need for Angular or Backbone. And the first part here is that we want to move state and business logic away from the DOM. All of the libraries I mentioned really focuses on this. So you should get this stuff away from the DOM and onto further back in your application. So MVC a lot of people mention MVC when we start talking about having more structure. And if we check Google Trends for JavaScript MVC, we see that it started in about 2005, 2006, and it's just growing quite a lot. So there's a lot of interest in MVC libraries for JavaScript. The main point here is just that we want some clean separation between data and the DOM. That's the model and the view. So the last part, the controller, is the thing that mediates inputs and manipulates the model. So it's this, you can call it the glue that sits between your model and the view. MVC is not the only way. There's lots of variations here among the libraries. So usually you'll see this instead, MV star. So that just means that you have some model, you have some view, and you have some glue in between. And that glue is very different between the libraries and the frameworks. So some of the patterns that you will see are, for example, model view presenter, where all the presentation logic is pushed into this presenter. So it's just a little bit different from a controller, not much. You have a model view model. This is more different because you can have bidirectional binding. So say that you update your model and your view will automatically be updated, or you do something in your view and it will automatically update the model. We're going to look at an example of that later. I think this quote by Igor Minar from the core team of AngularJS is interesting. He says that he declares AngularJS to be a model view whatever framework, and whatever stands for whatever works for you. So the entire point here is just that we need to separate state and the DOM. That's the main focus that we need to have. So that's the first step. We have come a couple of steps, and we're just starting here to do something different than the usual jQuery spaghetti. This MV star idea is not enough, though. I read this great blog post by a guy called Joel Hooks about, I think it's a couple of months ago, where he talked about his experiences with AngularJS. So Angular is one of the most famous front-end frameworks right now. And I see a lot of people really saying that you just need to use AngularJS and everything automatically works. He said that at some point they had lots of monolithic single files that contained too much code. This sounds quite familiar from our jQuery world. So code organization is still important. You can't just use some pattern and then everything is good. I also read a great blog post by Jim Levin where he talks about his experiences with what he called AngularJS modules. He says that how you split your code has an impact on the maintainability of your projects. So just how you actually separate code from each other has an impact. So my heuristic, at least what I try to tell people is on my team, is just create more files and have less stuff in each file. So it's very crude, but still it's an interesting starting place. So you just want to have more focused files that does one thing, or at least less than everything. So usually you could package your files by feature or by layer. So say now that you have 250 files. Do you have all those 250 files in the same folder or not? So for example here, if we package by feature on the left side, we can have a modules folder, and inside here we can, for example, have cart or a health. So the thing is that if you package by feature, you end up putting your files in folders so that at the top level, you could see some of the main some of the main parts of your application here at the top. So you can see on the left side that this application has a cart, that it has something to do with health. On the right side, we have packaged by layer. So here we have collections, models, routers, and views. This is from a Backbone application, and this is the main component in Backbone. So I really prefer packaging by feature. So because now I can see at the top of my application what's going on, at least some of the main parts of the application. So this promotes high cohesion. So you have, generally, it's easier to not mix everything together between views and between models and stuff when you separate them into their own folders. So a model is close to the view it works with. And I usually call these modules, perhaps a little dark here, but a module could be something like this. This is from Facebook. Here we can see the search box, which I would call a module. We could also have, for example, the status update could be a module, or the list of friends down in the right corner could be a module. So basically, modules are the pieces of your application that contains business logic. So you shouldn't have that all over the place. They should be focused in modules. So modules should be small. We saw the search box, that's a really small thing. So we should, at least in the beginning, we should relentlessly split into new modules. So just try to create lots of modules and just have them work on their own focused piece of the site. So they should do one thing really well. Modules should also be decoupled from other modules. So you don't need absolute separation, I think, but you should be able to move a module around on the site without it breaking. So with some of the jQuery stuff, that might be really hard. So you need to think a little bit differently on how you actually code up your stuff. So now, when you move this stuff around and the site doesn't break, it's easier to reason about what's going on. There's at least a couple of really good presentations on this. Nicholas Sakas has had a great presentation from his experiences at Yahoo. And Adi Osmani, who now works at Google, has a great presentation on decoupling modules. They have a lot of stuff, other stuff on modules too, but they're really focused on having very separated, decoupled modules. And I prefer modules to be reusable. They don't have to be, it should be a requirement, but the easier it's to reuse, for example, the search box on another page, the better. So all modules won't be reusable, of course. Some of them might need to be large, and some might not work in other contexts. But just thinking about reusability really helps. And I think that they should be easily testable. And actually, just by following these steps we've been talking about, they will be easier to test just because they're smaller. We're not working on the entire page anymore. We're working on this separate small piece of the application. So even though testing in JavaScript is still a little hard to do, it will be easier when you don't have the entire site to work on. Again, from the same book that I quoted earlier, they say that a system is easier to change if the objects are context independent. So that just means that each object has no built-in knowledge about the system in which it executes. So basically, when you have something on your page, it doesn't know about all the other stuff. If it needs to know, you should give that module the data it needs to know about. But basically, it should know what's in the DOM in some other place. Does the search box on Facebook need to know about the chat on the lower right corner? No, it really doesn't. So if it needs to know something about the chat, we could send that stuff into the module when we create it. So just a couple of basic module rules. These are very inspired by Nicholas Sakas, one of the presentations I mentioned. He says a module should never access the DOM outside the module. So that means if you have a module, it can't just go and update somewhere else in the DOM. It needs to update within its own borders. So now you don't have these pieces of your application that update some random place. So now it's easier to move stuff around and do stuff. For example, you can remove a module without the site breaking. And a module should not create global variables. Just having global variables at all makes it really hard to reason about what's going on. So we should prefer to not create global variables. you might have a namespace, for example, where you put all your JavaScript on, your state on, and that might be okay, but you shouldn't create a lot of global variables. And you should prefer not to access global objects, global variables that are not native to JavaScript. So we've taken a couple of steps more. So now we both have this MV star type of separation, and we have this concept of modules. So just by following these steps, we have now started thinking differently about how we work with our applications. So another very important thing to think about is dependencies. So usually when we code, we depend on a lot of stuff. For example, at runtime, we depend on some other code. We might depend on jQuery, we might depend on some state or some logic in our application. We might depend on other files, for example, just having the jQuery file loaded. And we depend on third-party libraries, Underscore, Backbone, Angular, jQuery. So we're just going to take a look at each of these in order. So first, we depend on other code. We usually depend far too much on globals. So, and JavaScript makes this really easy. We can just take an example here. If we have this 5 lines of code that we started with, this seems really easy. But the thing is that there's a lot of problems here when our application grows. First of all, this function that is called when submit, when the button here is clicked, this function cannot be called in or reused in some other context. So if we have somewhere else that we want to perform the same function, we need to code that stuff again. It's also really difficult to test because we now have to set up the DOM, we have to put this button into the DOM, and we need to click on it. Then we could have this IX request and update the DOM. And we also use a lot of globals here. One thing here is just jQuery itself, so in jQuery get method on jQuery, but also this thing here, which is in the DOM, is also a global. So just by doing a little change here, just by naming this function, it's now easier to test. Now we can call download emojis in some other context. We could also reuse that if we need to do the same thing when you do something else than clicking on this button. We still have to test. We might still want to test this, but it's still a little bit difficult because we are actually doing an AJAX request and updating the DOM. So taking it one step further, we could start passing in, injecting the dependencies here. So now we say down here, we say that we want to send in, for example, this result, where the position where we want to update the result. We could send that in. And now, when we get the result, it updates this jQuery object. So in a test, we could now send in something else than this. So it's easier to test, and it's easier to reuse in another context. So now we can control the dependencies, and that really helps. So now, for example, if we wanted to create some higher level helpers for AJAX or something, we could pass them in here as well. So instead of just using jQuery, it will be far easier now to create something else and send it in. I wrote a little bit about this about a year ago on my view abstraction that was based on some of the things I've been doing with Backbone. So one of the problems we had was that I was working in mobile banking, and I really wanted to have good tests for my JavaScript app. And that was really hard when we first started out. So we created something like this. This is just inspired by Backbone. We have a user view here. I can try to point here. We have this user view, and when we create a user view like this in JavaScript, we can write new user view, and this here will be for that instance. So here we pass in someplace in the DOM here as a jQuery object, and we pass in this object with just image. So now, if we add some method here to the user view prototype, we can have an instance method. So now, if we call show image, that will actually do this stuff on the jQuery object we sent in. So when we do this, we could actually write tests without having the DOM present at all. So in our actual code, we might include this, but in our tests, we can do this. And now you only need to check what's in this jQuery object. So you don't need to work directly on the DOM. So with this technique, we had, I think it was about 500 or 600 tests running in about a second. So it's lightningly fast. And I ended up just running my tests the entire time. When I came to work in the morning, I just started the test runner, and I just sat there coding and could just see red, 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 green, perfect, the entire day. And it's just amazing when they run all the time. So you don't have to wait 10 seconds or 20 seconds or whatever. They could just run. And the test runner I was using, which is called Karma, it's really stable and it's really good. So it didn't fail when I had this crazy, strange stuff going on in my JavaScript. So if I saved at the place where the JavaScript wasn't compiling properly. So this was great for our team. Now we could easily write our tests and just run them all the time. So the thing I was just trying to say is that you should always inject dependencies. That's changed our code quite a lot. It makes it easier to work with and also easier to test. AngularJS is a framework that has really embraced this. We could look at an example here where you have a controller. So a controller means something specific in Angular. It doesn't matter what it is. But we have this function here where we say send in something called a scope and HTTP. So these are things that we get from Angular. But the thing is, these two things, they don't need to be in that order. We could just change them around, and the code still works. So AngularJS does some magic here. It's really not that magic. So we're going to look at an example of how it actually is done inside of Angular. But the thing is, now this doesn't matter at all. But still, sending them in is very important, because now there's nothing in here that works on something that is global. This only works on the stuff that is sent in. And as long as you do that, actually increasing to 10,000 lines of code, 20,000 lines of code is far easier, at least in my experience. So to look at how AngularJS does this, we could create a module. So this is kind of like how we talked about modules so far. So we create a module called conf, and inside, and it has no dependencies. So that's just the array at the end. So on this conf module, we create a method. This method is going to be called awesome. So this is just how you can create stuff like that in Angular. It's a little bit different. And now we create something called an injector. It's just this piece of code that is responsible for finding the dependencies and pushing them into your function. So here we see that conf is the same as our name up there, and ng at the end is just AngularJS internal stuff. And now if we invoke the injector here, so we see that we have injector.invoke on this function here. So this function says that we want to use awesome. And now this injector here, it goes and finds awesome here. So it goes through these and looks if it finds anything with this name. And then we can output the information. So this is really different. I thought this was really, really strange the first time I saw this. But it's also really interesting because it's really different. But it makes it really easy to follow this pattern with sending everything in, because that's the way you do stuff. So AngularJS is really built around this from the ground up. They also have another cool feature called two-way data binding. This is something that is present in a lot of new frameworks. And the general idea is that you have some JavaScript object, and you have some something that is going on in the DOM, and you can just combine them together. So you could say that when this JavaScript object changes, update the DOM. And when you, for example, input something in an input field in the DOM, update the JavaScript object. So you have this connection between them. So they automatically update. So now all the states, all the things that are in the DOM, you also have access to in JavaScript. So you no longer have the DOM as the state, as the source of truth. Ember, we can just take an example with Ember. We have this template. So this is a template that is rendered on the front end. So we say that if this is supposed to be expanded, we want to write out a div here with the body. And when you click on this button, it should call something called contract. And it says contract here. And when it's not expanded, it should be here. And also have a click action which displays the information again. So now if we have a controller in Ember connected to this template, we can see that it defaults to is expanded been false. So it starts out here. When we click on expand, it hits this function here. And then it says update is expanded to true. And now automatically the DOM will update to this without us doing any kind of jQuery stuff at all. So it's also a little bit different, but I recently created not a big app, but a reasonably big app where we didn't include jQuery at all in the application. So this was just, we tried to really test this and see how it worked. And we really didn't need any jQuery at all because we handled it using this built-in functionality in Ember and Angular. So this means that we get rid of some of the low-level stuff that we do. So we tend to fetch things in the DOM, do some stuff, and we need to think about updating that in the DOM. We need to think about the state being consistent here and stuff like that. Now we don't have to think about it. It happens automatically. And going further with dependencies, we can start looking at other files. Usually in our index.html, we have this ordering of script files that matter. If you take jQuery and just move it to the bottom, code will usually break. So when you have, at my last project, we had about 250 files. So now, when you start moving those around or start adding new stuff, you really have to think about what order stuff is in. And I really don't want to do that. I really like being able to say, I want my app and just fix all the other stuff. It doesn't matter for me what order they are in. So there's also a problem that we have usually lots of globals when we have all of these files like this. So, and another problem is that we have weakly stated dependencies. So if you go into one file, it's hard to see which files it depends on. So you need to go looking for jQuery underscore and all of the other stuff to see which files are actually used. So if you have stopped using underscore, but you really don't know because it's not easy to see that in your application, you will still include underscore even though you don't need it. So there are a couple of interesting things going on in the JavaScript world here. You have CommonJS, which is the way Node.js handles modules on when you use JavaScript on the backend. We can see an example there first. It looks something like this. You say that we want to require jQuery, and the result of this require is then put into this variable. And if we want to export something out of our file, we say exports dot and the name of the function. So now we can then see at the top of the file which things do we depend on. AMD is another approach here, where it's quite similar, but here you say define, you say your dependencies, and then asynchronously, this is synchronous, this is asynchronous, so here we have a callback function that is called when we have found all our dependencies. So here we see jQuery, and we want to use $ inside our code. And what we return here is what's available for other files that require us. ECMAScript 6 is the new standard for JavaScript that is being standardized right now. There's this module stuff coming in. I don't know if it's if it's finished. So I don't know if it's going to be precisely like this, but here we can say that we want to import $ from jQuery. And we can also export stuff out of this file. So these are just different ways of handling modules in our code. Right now, AMD works better in current browsers. So you can use CommonJS, which is used in Node. You can use that in the front end with a library. And you also have some stuff to get the ECMAScript 6 modules working. But just to look at an example here, we could see, check out required.js. I've been using required.js for a couple of projects and been really happy about it. So in required.js, you usually have one script in your HTML. So you say that in the script, you say that you want to include required.js, and you want it to load this file. So this is the config file for our application. And this config file can have some basic config, which are our libraries, where are they? So now when we say that Backbone here is in the lib folder, we can just say we want to include, for example, jQuery. I just want to include jQuery. And then it will go find jQuery here and find it in the lib folder. And otherwise, it just follows the folder structure you're in. So here, if you say app, it finds app.js in the current folder. And then when you say new app here, with this dependency, it ends up finding all the dependencies here. So for example, app.js depends on Backbone, Backbone depends on underscore, app.js depends on a lot of other stuff. But now you don't have to think about the ordering of script elements. Now the tool is responsible for finding a file that you need and finding all dependencies for that file. So now you have this tree of dependencies. So the last topic for today is third-party libraries. We have to keep things up to date. I worked in an application with about 20,000 lines of code, and we depended on about 30 or 40 different plugins and frameworks and everything, from underscore to some different, for example, accounting.js for some currency stuff, and moment.js for dates and stuff like that. So to keep that up to date, we had to go through these, all of these files. We had to go to their web page and see if there are any updates. So on the back end, for example, in Java, you have Maven. In Ruby, you have Bundler. In Node.js, you have NPM that can do this for you, so you don't have to think about this yourself. Now on the front end, there's a couple of libraries coming. One's called Component, and another is called Bower. And Bower just reached 1.0 recently, so I think it's quite good right now. And when you have Bower, you could say that you depend on some stuff. We depend on Angular version 107, Angular Resource 107, and jQuery 191. So now, when we type Bower install, Bower goes to GitHub and finds all of these dependencies and just downloads them into your folder. So now, if you want to see if there are any updates, you could type Bower list, and we can see here that jQuery is outdated. And we could also see that Angular resource depends on Angular. So now it's easy to see which files, which libraries depends on which libraries. So I've just used this for a couple of months in my current project, but we're quite happy with it. It simplifies just ensuring that things are up to date and just handling all these libraries. And if we type in bower install -- save and the name of the dependency we want to include, it automatically updates this list with it. So you don't have to do that yourself either. So that's as far as we'll go today. We have been through a lot of stuff. There's a lot of new stuff. If you're not used to, if you haven't checked out this stuff before, there's a lot of new stuff here. So you might think, is all of this stuff necessary? I don't think all of it is. I think the mindset of just thinking about building larger applications and how you should change what you usually do. You can see on your own application what works, what doesn't work, what are the problems we have felt in our team. And you should just start to think about how could we change that. So these have been my experiences. This has been the exact path I've been through this last 3 years. Just learning about MVC, starting to think about modules when we saw that we had large files and things still didn't work. And then we started thinking about dependencies and how we should handle all those stuff because we started having 200 files in our index.html. So all of this isn't necessary at all. Just starting to think about large applications is. So if you want to learn more, me and a couple of friends created this page earlier this year. We tried to just collect the best articles, presentations on large-scale JavaScript apps. So there's quite a lot in here. So you could just find something that is related to what you're interested in. So, and also if you have any articles or stuff like that that you recommend, please let us know. So that's all. This is the link to the presentation. Thanks. Any questions?
Hi. Thank you for this inspiring talk. I really have to catch up on like all of it, but I have a question. Do you heavily rely on client-side templating? I saw you took.
Yeah, we've been doing a little bit of both, relying on both client-side and back-end render stuff. But we have done it quite a lot, relying on front-end templates. So, and we have, some of it might be a little slow, so we started thinking about how we could make that faster. So we started pre-compiling our templates into JavaScript on the server. So we started adding more. So of course there's more complexity here too. But then everything was JavaScript and the page really speeded up, especially on mobiles, especially on older Androids. We had a lot of problems there. So, yeah.
And yeah, that would be my next question. So regarding performance, did you test it client side? Are you sensitive to this area?
Yeah, so we, I really think it depends on what type of thing you're making. In my last app, that was primarily a desktop app, so it really wasn't meant to be used on a mobile. And there wasn't any problem at all there. But especially if you need to think about mobile, you need to think more about it. But just when we pre-compiled it, that really helped. But of course, I've heard that, for example, Twitter, I don't know who, a guy who worked at Lanyard, he talked about they have changed to rendering stuff on the backend. Twitter has changed to rendering stuff on the backend instead of having a single page app. And that really sped up the application. So for the applications that I've been working on, we haven't felt a really need for moving that stuff to the back end again. So, yeah.
Did you ever use TypeScript in a project?
I haven't used it, but a couple of people in my company has used it, and they had really good experience with it. So I can't talk from my experience, but at least they've been hyping it really much inside our company. But as we are consultants working for a couple of large companies, we really can't push it yet. So they used it on some internal apps. But I really think that TypeScript is really interesting. And for me, at least, I think it's more interesting than CoffeeScript, because I really like some of the ideas just being stricter, and I think that works better when you're building a really large application. So, but I also like Java, so I might not be the guy to ask about this.
Just a quick question about the organization. You said you prefer putting everything in its own module. You include templates there.
I didn't say it now, but I include everything. I include templates, I include the CSS, I include the tests, I include everything related to that piece of functionality goes into that folder. And that was really great in my last project where we really tried to push that idea. It worked out really well, because you always had the related files just close to each other. Normally, when you work on something that's working on the view or the DOM, you often need to do some CSS stuff at the same time. That's close to each other. And also, it's really easy to see when you have specific CSS for one module and when it should be global for the entire site. So I felt that it made the CSS better too, just thinking this way. So I think it's an interesting idea, just include everything in there.
Do you have any experience of converting Java developers to front-end developers?
I have a little bit of experience, but actually, I had a couple of friends who were primarily Java developers who started using AngularJS, and they actually thought that it was very easy compared to Backbone. They also checked out Backbone at the same time. Because a lot of the ideas, those who created AngularJS, they were Java developers. So there's a lot of ideas that are similar between them. So, but generally, it's not that easy, especially if they haven't used JavaScript at all. So the most important thing is just getting them up to speed on not just jQuery, but I don't know, talking to them about do the same thing you do on the back end. So think about how you organize stuff, think about how you structure everything, instead of just allowing them to do jQuery spaghetti stuff. So I think it's weird that a lot of people that work in Java really are strict about how they build stuff on the back end, but then on the front end, they just go along and just creates crazy jQuery stuff. So I really haven't got any specifics for you.
Regarding the question that was asked about templates in modules, how do you include them in the end application, in the end HTML? Do you use kind of web components with fallback or dynamically inside in HTML or what?
I've been using require.js for a couple of projects, and there it's really easy to just say use this HTML code, so or download this template. So require.
Do you mean text plugin or what?
Yeah, so I mean using require.js with some kind of plugin, so the text plugin or something to require.js, and say download this file, and then you can say when you optimize your require.js code, you could say to so require.js has its own optimizer, so you can create everything into one file, and here you can say that you should also pre-compile the templates. So I use, I don't remember what the plugin was called, but.
So after that, you just include it as simply in HTML, or do you compile it to DOM nodes? So?
Yeah, so it just fetches this. In development, it fetches the file as just pure text, and it compiles it. And in just the optimizing step, when I create everything into one file, it actually saves the compiled stuff. So this is just a tool that does it. So I've also had a couple of friends to just loop through all of the templates. So if you have some kind of naming of it, for example, template name.template.js or something, they just loop through them and minified them or created this, pre-compiled them and saved them into just a jQuery object. So they created a jQuery object and saved that to a file. And then you could just use that, for example, templates dot and the name of the template.
Okay, thank you.
Perfect. It's time for party.
Thank you, Kim. I got two informations for you. One concerning Lightning Talk. So before the party starts, it's the last time you can actually enter Lightning Talk, and we'll contact you tonight. The second one is the party. We would like that you gather all at the lobby. There will be 3 groups formed. Always 2 of us will guide you then to Frau Gerold's garden. If you want to go by yourself, it's at